Wow, I hate it when this happens. I'm having to re-record this because the last video I had didn't involve a microphone. So I had my microphone turned off. Recorded the whole lecture, almost 20 minutes with no audio. So we're going to go back through this again. At least I'm going to go back through it. This will be the first time you've seen it. This is Module 4, the second lecture video. In the first, we talked about comments and how to extend a statement down to the next line. Now in this lecture, this video, we're going to talk about conditional statements. And in conditional statements, the conditions are things that we've dealt with all our lives. If I do this, and it's what I was told not to do, I'm going to get in trouble. I know what's going to happen if I do this. So we're going to have some kind of conditional if, and beyond that we're going to have the condition. Now, in the code, we have an explicit way of doing things and an implicit way of doing things. This is explicit. If disaster is equivalent to true. And I'm going to talk about the word equivalent in a little bit. This is not equals. Try to avoid using the word equals. If disaster equals true. Equals in programming, in coding, is an assignment operator. This equals that. I assign that value to that variable. This, it's a comparison operator. If disaster is equivalent to true, that's a special equivalency, or they say equality operator, comparison operator. So if one thing is equivalent to the other, if they're the same, have the same value. Now, in this code we see up here, they're very implicit. Because if disaster, well, where's the equivalency? We go look in this variable and see if what's in there is true. This only works if this is a Boolean. And in this case, disaster is a Boolean. It has the value true. Make sure you have that uppercase T, because little t does not mean it's a Boolean value of true. I could have said if true and just had that word as we see it right there. Uppercase T, lower r, lower u, lower e. And in your notebook, your exercise notebook, you go in and play with that and see what happens. If you say, if true, print something. Else, print something else. Well, there is no alternate condition that can be met. We're saying if true. It's always going to be true. So it'll always go to the one, not the other. We'll deal with that concept in the repetitious structure, or the loops, when we get to them. We'll actually do something like that. But in this, disaster could have a value of true or false. What's the data type for disaster? And we know just by looking at this. It's a Boolean. So this conditional statement, when that condition is satisfied as true, this next line will be executed. When that condition is not true, or the condition's not met, we come down to the next statement. Else, we've got to have this symbol in there, that colon. I'm going to talk about that in a second. The else is when things are not conditionally met. This is our false side of it. So, how many output statements are going to be made? Just one. One for true and one for false. If I changed this value to false with a big F, the second statement, the else, would have been executed. Now, I'm wording that the way that I did. This statement would have been executed because that's the way it works. If true, we go here. And then we're done. We don't come down to the else, because else is only when that's false. Do I have to have an else statement? No, I don't. If true, do this. Well, what if it's not true? Doesn't matter. So conditionally, we deal with things like this all the time. I look out the window right now. Man, I'd like to go to the beach. But I've got a condition on going to the beach. If it's nice and sunny, go to the beach. It's not nice and sunny today, so I'm not going to the beach. I didn't have an alternate in there. If nice and sunny, go to the beach. Else, record videos for the class. All right. Well, there's a plan B, if you will. There's the what are you going to do if that first condition was not met? We don't always have to have a backup plan, but we try to have a backup plan whenever we can. So with that said, this, how it's written, is very implicit. Here's the explicit syntax. Do you have to have parentheses around it? No, you do not. But be safe. Wrap these things up in parentheses, much like if you were doing math. Know that at the end of that statement, at the end of the condition, put a colon. That way you're telling the computer, here we go. If that's true, this indented next line is what we're going to do. And when I say indented next line, the IDEs are the environments that we're using, whether it's Replit, or if we did the notebooks, Jupyter Notebooks, if we did Visual Studio, whatever environment we're using, once we put that colon in there and we hit enter, traditionally the IDE will automatically indent the next line because it knows that is what happens when that's true. If I hit at the end of this statement the enter line, it would bring me down and automatically indent me in the same amount. I will then have to tab back, right backspace, to get back to align with the if. For my else, that's the what happens if that's false. Indentation is key in our coding. Formatting is key. Formatting is more than just what we talked about in that first video, this module, with the comments and white space. Indentation's a big deal. So these logical structures, we need to have comments. We need to have white space. We need to have the correct indentation for this to work right. Okay? Most of the time, if not all, it will automatically put you where you need to be. After you put the colon, it'll indent you. These symbols tell the computer what's happening in there, or will tell our IDE what's happening. Much like in other languages, Java or C# or C++, you put that semicolon at the end of a statement to let it know that's the end of that statement. Colons mean something, and they tell the compiler how to go through and evaluate each line of code or each statement. Okay. The print, we've dealt with that function in the past. There's the print statement. We're invoking or calling that function. It's the print function, and we're passing it that value. So it's almost like we're outsourcing some work to somebody else. Say, hey, print, you know that thing you do where you display words for me? Yeah? Do that with what I'm passing you here in these parentheses. Okay? That's all I got to do. As long as I know what print needs from me and in what format I have to pass it, I can use it. Now, when I'm talking about functions or modules or methods, I should say, in other languages, functions and methods, that's synonymous. I need to know, and I'll talk about it later, I need to know what does that function need from me, and in what form does it have to be in. What is that function going to do for me or provide me? And if it's giving me something back or returning me some value, what form is it going to be in so I know how to handle it? We'll talk about that in a future video. But for this, it's a print function. I call it or invoke it, and I have to pass it some value. It needs something from me. And whatever's in there, if it's in quotation marks, that is a string literal constant, and that will literally be printed exactly as we see it. I'm not tied to just strings, string literal constants, as we saw there. We'll deal with that, like I said, in a future module. So for this, here is the if-else logic. So we've got an if statement, if, and that's implicit, we dealt with above, if furry is true, equivalent to true, and I could write this explicitly. If, parentheses, furry, the equivalent symbol equals furry, close parentheses, colon. Same thing, it's just this is implicit, the other's explicit. Colon, indented. Well, we've got another condition. Colon, indented. Condition's not met, then we've got the else to account for it. Boom. Well, what if furry were false? Else. What if furry were true? We dip down in. What if large is false? Dip down to else. What if large is true? We print. It's a Yeti. Okay. Furry's true. Come down. Large is true. It's a Yeti. If furry was false, we come to the else. If large is false, it's a human or it's a hairless cat. It could be a chupacabra, whatever it may be. So, from there, we only have one output statement that will end up as a result of this logic. If we wrote this out as a decision tree, we would have a line. One of two things happens. Either furry is true or furry's false. Furry's true, furry's false. We go down that decision tree. If furry's true, well, then we have two more branches. Large is true, large is false. If furry's false, large is true, large is false. So that's how we have it broken out there. Okay? In the next video, we're going to talk about switch statements. or case statements, something that does not exist in Python. Python's a very light and small grouping of functionalities. We don't have all the built-in things that some other languages will have. And a switch statement or a case statement is some built-in structure. We don't have it in Python, but I want to talk about it, and we'll talk about it in the next module. Or not in the next module, in the next video, video 3 in module 4. Now, one of the things I want to talk about before we go on to the next video, only a couple of minutes here and we'll be out of this. In these if statements, we can have a single condition. That condition involves comparison operators. We're comparing two things. The example I had compared them to the value true. We're not limited to just the value true. It could be I'm comparing two strings to see if they are identical. It could be I'm comparing a variable that has a number in it with another variable that has a number in it. Variable that has a number in it, I'm comparing it to a static number or a constant. So I'm comparing two things. And the examples that we had up there were furry, true. Is furry true? Is furry equivalent to true? Well, is furry not equivalent to true? Is num1 less than 4? Is num1 less than or equivalent to 4? Is num1 greater than 4? Is num1 greater than or equivalent to 4? Should be okay with that logic. It's things you've dealt with in math in the past. Now there's some mathematical operators or comparison operators that we've talked about, and we'll talk about more in the future. The symbols for and, symbols for or, what represents and, what represents or, and you will use them when you have multiple conditions that you're evaluating. For now, we'll deal with one condition. At some point, we're going to deal with multiple conditions, or have you do an assignment based on somebody entering in their grade and you determining is the score they gave you an A, B, C, D, or an F. Okay. So I will see you in the next video.